Okay, and someone want to answer, what do you notice? About what? Over the x-axis. Okay, is everybody okay? So can you write a general statement as to how you would flip a function over the x-axis? Write me a general statement. Right, okay. Be very precise, okay? Do not be sloppy, okay? This is math. So what you're going to do is you're going to call the new function with a new name, g of x, right? And then Surbir, you write it like that. Yeah. Okay. Writing it like this is kindergarten. Okay, that's kindergarten. You write it as minus fx. Is everybody okay on this? This one? Got it? Okay. What happened to your boyfriend? Lisbeth? Come on, that's what I mean. That's, yeah, I know, duh. Okay, is everybody all right? How to flip over the x-axis? Is everybody okay? Yeah? Okay. Okay, wow, this is teacher will demo this one. Woo! Okay, let's go do it. Okay. Boom, done. It's there, done. Okay? Aren't you envious? Aren't you envious? Wouldn't you like to be able to do that just like that? Right? Okay, and then what does it tell you to do? Next. And graph minus x quantity cubed, x cubed. Okay, so let's go graph new function, and I want parenthesis negative x to the third. Can you see which one's which now? Yeah. Okay, so I should have really changed the colors on these guys. This was my original one, so let's make that red. Red's good. And let's make this one black. Wouldn't you like to have this stuff? Okay, so let me go label these things properly so you guys can see. So this one is fx equals x cubed. Okay, and this one is g of x equals minus x cubed. What do you notice? What do you notice?
Flipped across the y-axis.
Thank you. Flipped across the y-axis. Can you give me a general statement as to how to flip over the y-axis? Fantastic. Good job. Good job. Is everybody with him? You want me to write it down? Is everybody there? Is everybody there? Does anybody want him to repeat that? Okay, go repeat it.
G of x equals f parentheses negative x.
Is everybody there yet? Yeah? Is everybody okay on this? Okay, so to flip over the x-axis, you stick a negative sign in front of the f. Okay, to flip across the y-axis, you change the x inside the f with a negative x. Is everybody okay on that stuff? Okay, Josh? Oh, you got to do this. Because this one's easy. X squared. Done that, been there so many times. One more time on another square, on another square. On a graph paper, on another square, start graph x squared. One more time. Anybody want to complain about it? Anybody want to complain, Surbir? No, see my fist here? Anybody want to complain? Or is it going to be tuppered for you? Got it? And then do 2fx on the same graph. Then do 2fx on the same graph. number less than 1. Okay, if you multiply by a number more than 1, it's going to kind of shrink in like that, collapse in. I don't like the notation that you guys were taught in Algebra or 2 in that Holt book. It's extremely confusing because they tell you take a reciprocal and then, if you want to open it, you do this. The process that we talk about is just called scaling. Okay, this process that I just did of multiplying the function by a number, whether it's more than 1 or less than 1, is called scaling, just multiplying by a number. You guys with me on that? Okay, so I don't use the concept of, how would you open it up, how would you close it? I don't use that concept like your Algebra 2 book does, okay, because it's extremely confusing. So I'm just going to say, okay, scale the function by 6. That means you're going to take the original function, multiply it by 6. You guys with me on this? Look so tired. You're going to pass out here? It's only 4th period. It's only Thursday. So what's the excuse, Elizabeth? What's the excuse, Elizabeth? No excuse? Oh, you're not tired? Okay. I'm tired, I'll tell you that. I don't know why I'm tired, but I am tired. Okay, let's do a different set of problems. So what we're going to do is we're going to put all the transformations that we did yesterday and today, combine all of them, okay, and come up with a new function. Okay? Kind of combine all of them and come up with a new function. So here's the example. So let's start working on this. No, we're not graphing right now. We'll graph in a minute. Actually, let's do this. Let's do it in 2 different ways here, okay? Let's first of all do it by graphing. Let's do it by graphing. So on a separate box, on a new box, graph square root of x. You guys really need to be quiet there, Miriam. I'm really getting annoyed now. It's extremely distracting. You guys want to chat? Go pick a spot at the back. I'm okay with it. Okay, you can chat to your heart's content. Square root of x. Okay, you should know what square root of x looks like. Okay, it's one of those famous functions. You've got to know what its shape looks like. Yeah, question. Yes, you're graphing that on a new box. Graphing that on a new box. Okay, you're going to shift this right by 1, which means that your graph is now going to go, this point is going to come out here. Everything is going to move to the right by 1. So it's going to look like this. Okay, so if I say that this one is square root of x, from yesterday, can you tell me what the blue one's going to have? What equation will the blue one have? Sorry? Where? Can you give me the whole function? Don't just say plus 1. Where? Square root of x plus 1. Okay, because I could have thought it's square root of x plus 1 on the outside. Is it? Aha. Is it? Are we having a fight here? Is this right? This is not right? It should be. Thank you. Okay, when you go to the right, it's counterintuitive, okay? It's negative when you go to the right. Okay, it's counterintuitive. Shift down by 2. Shift down by 2. So you're going to take this function and move it down 2 units. So it's going to look like this. See how I draw these things in different colors and I write in different colors and I write it right next to the graph? Then it's very obvious as to what's what. Okay? What would the black equation be? What would the black equation be? Sorry, I can't hear you. Can you raise your hand one at a time? Ryan. Yeah, go. Did I get your name right? Ray. Ray. Subtract 2 from it? Like that? Okay, is everybody there? Okay. Next one, you're going to flip over the y-axis. I'm going to be running out of colors here. Flip over the x-axis. Flip over the x-axis. So then, what's it going to be? So this point here is going to come out here. Is everybody there? This point here stays where it is, right? If it's on the x-axis, you can't flip it. It stays on the x-axis. Okay? This point here is going to come out here. So your graph should look like this. Is everybody with me on this? And what would the equation be? Be careful and raise your hand if you have an answer. Okay, be thinking. Zara. Sorry? Okay, I'm not going to put G here. I'll do it later. But right now I just want, okay, turquoise. Times? Why times? I'm doing number 3. I'm flipping over the x-axis. What happens to the negative 2? That becomes plus 2, doesn't it? Because you're going to take this. Remember, this is a function. Isn't this a function? Isn't this square root of x minus 1 minus 2? Then remember, if you want to flip it over the x-axis, you stick a negative sign in front of the entire function. Right? Negative fx. Is everybody with me on that? Yeah. So if you stick a negative sign in front of this whole thing, make sure you use your protection there, which would give you negative square root of x minus 1, and then it would be plus 2. Is everybody with me on this? Yes. Okay? And then scale by 2. Scale by 2. Scale by 2, what's going to happen? So this point here, wherever this is going to be twice as big. So it's going to be there. Right? Is everybody with me on that? This point will stay where it is because it's 0. The y value is 0. This point is going to be twice what it is. So it's going to be here. So your graph is going to look like this. And this guy is going to be. So what's your final equation going to be now? You're going to take the turquoise stuff. Okay, you see the colors there? You're going to take the turquoise and... Okay, let's take it step at a time. Okay, we're going to go 2 times everything in parentheses there. Is everybody with me on this? Yeah? Everybody got this down? Okay. This is if I ask you to graph each one of these transformations one at a time. Okay, if I tell you do number 1, 2, 3, and 4, this is the way you'd end up doing it in graph. Okay. How do we go about doing it algebraically? Okay, how do we go about doing it algebraically? So let's take another look at this again. So notice the specific way that I go about doing this, okay? So this is fx, okay? For f1, which is step number 1, I want to shift right by 1. So I'm going to take fx plus 1 or minus 1? Minus 1. And what I do is I take this and put it in the place here. So then it becomes square root of x minus 1. So now my purple or whatever that color is, I think it calls it fuchsia. Does that look like fuchsia to you? Okay. So my fuchsia function is square root of x minus 1. That's f1. Now I'm going to go to step 2. I'm going to shift this down by 2. So this is the way I'm going to write it. f2 of x. I'm going to take whatever f1 is and shift it down by 2. Is everybody with me on this stuff? So then this becomes square root of x minus 1 minus 2. Okay? Someone help me with number 3 then. Udara, I'm really getting extremely frustrated with you and these girls here. I've moved you here twice. I've told you this is your permanent place. Even then you choose to ignore me. And I'm being extremely serious. Next time I call your name out, you're going to be out of the classroom. Okay? Got that? Okay. Number 3. So, someone help me out with this. Yeah, Sona. Wait a minute. Look at the sequence. Look how I'm going. What am I going to start out with? Nice. You're going to flip over the x-axis. Nice. Okay. Notice what you are doing, okay? When you are working on F3, you're going to work on F2. So, Vikram. Nice, good job. And then, fantastic. See how it's going in sequence? Okay? All right. And then the next one. Yellow doesn't show up too well. I might show up there. I'm not sure if it'll show up on my screen here. So, okay, next one. Where are we? Mariam. F4. Whoa. I'm going to work on F3. What am I going to do to F3? Multiply by 2. So your first step should be that. Then you'll take the 2 and distribute it out. What do you get? Plus 4. Everybody get the process of how you transform functions? Is everybody okay on this? Sorry? Yeah. Okay. You guys get to do this problem then. Okay. So use fx equals x cubed, then write the equation of the function g of x after the following operation. So you're going to go f1, f2, f3, f4, and then you're going to call f4 what? What are you going to call f4 finally? G of x, because that's what it wants the result to be. No, right now we're going to do it algebraically. Yeah, we're not graphing this right now. We are just writing the functions. Okay? And then when we do get g of x, we'll graph it. Okay? Is everybody with me on that?